So the linear programming question then is question 8. So this is about the cake shop and selling Christmas hampers. So we've got two sizes of hampers, X for luxury and Y for special. So X for luxury and Y for special. 10 minutes to prepare a luxury hamper, 15 minutes to take a special hamper. She's got 6 hours available each day for preparing hampers. So what we're being asked to do is to express all of this as a linear programming problem. So the first one is show that x and y must satisfy the inequality 2x plus 3y is less than or equal to 72. Now the problem is talking about a day. So if we look at how much we sort of know about the day, she's got 6 hours available each day. Okay, so 6 hours available each day, and she takes 10 minutes to prepare a luxury hamper, and she takes 15 minutes to prepare a special hamper. So what we can do then is we want to talk about this in minutes. So it's 10 minutes for each luxury, so 10 minutes for every x plus 15 minutes for every y. And that's going to have to be less than or equal to 6 hours. Now obviously we've got mixed units here, so we need to change our 6 hours into minutes. So 6 times 60 minutes, so it's 360 minutes. So this is our first inequality for this problem, and this is the one that satisfies 2x plus 3y less than or equal to 72, because you should be able to see here there's a common factor of 5. Show that you're dividing by 5, because it's asking you to do a show that. So we're showing we're dividing by 5, which gives us 2x plus 15y is less than or equal to 72. So that was question 1. In addition to part B then, so in addition to the x is greater than or equal to 5, y is greater than or equal to 5, which is this line here, she needs to prepare at least 5 hampers of each size. We need to find 2 more inequalities. So from this next statement, she will prepare at most a total of 32 hampers. So x plus y is less than or equal to 32. So when you add up the number of special and the number of luxury that she creates, there'll be 32. She will prepare at least twice as many luxury as special. Now this one caught out a lot of students. They went for 2x is greater than y, but the correct inequality for this one is that x must be greater than or equal, because it's at least twice, so twice would be equal, to y. So if you double the number of special hampers that she creates, that will be at least equal to, if not smaller than, the number of the x hampers that she creates. So the number of, the number of luxury hampers. So the number of luxury hampers is double or more the number of special hampers. Take your time to get your head around this inequality. It's this type of one and the ones with percentages that really do trip students up. So we've got these 3. So our 3 inequalities so far are the one that we've been given and these 2 new ones, and the other 2 will be x is greater than or equal to 5 and y is greater than or equal to 5. Then it says on the grid opposite, draw a suitable diagram to enable this problem to be solved graphically. Indicate a feasible region and the direction of an objective line. So we still need to know what our objective line is. And it comes from this last statement, which again I'll just highlight in yellow. Each luxury hamper that she creates, prepares for profit, is £15 profit, and each special hamper gives her £20 profit. So the objective function for this problem, the thing we're trying to maximize, is 15 times the number of luxury hampers, so 15x plus 20 times the number of special hampers, and that's going to equal her profit. There we go. So I've just jigged things around a little bit so that we can see everything that we're doing. So now we need to draw on here all of these inequalities. So we'll start off with probably the two most straightforward lines, which are x is greater than or equal to 5 and y is greater than or equal to 5. So if we draw on the line y is equal to 5 here, so I haven't got my straight line tool, here we go. Draw on y is equal to 5 and we want to be more than that line. So I'll just move that up into the right place. So we've got our point of y is greater than 5. So everything above that first red line. Then my second red line at x equals 5. And again, everything to the right of that line. Now, what I'm going to do is I'm just going to do some very simple shading, just coming down here to show I'm shading out this region here that I don't want. I'm not going to go mad on the shading. I'm just going to do quite a simple shade across. So I'm just going to tick them off as I go. Let's now do x plus y is equal to 32. X plus y equals 32. So here, this is, if we go for the x and y 0, 0 method, we can see that we've got to plot a point at x is 0, y is 32. Now, one thing that you did need to work out here is that the scale is 2 little squares is 1 whole. So we're going to go up four little squares here to put in my point. Similarly, I'm going across from 30, 4 little squares. So those are my 2 points, and again, join those up with my straight line. Now, I want x plus y to be less than 32, so I want below that line. So again, I'll just shade that out. Before I go any further, I need to remember to tell you one of the most important things you should do here is label every single line. Now, the reason why this helps is this firstly helps you, reminds you which lines you've drawn, which lines you haven't drawn, and it helps your examiner. And you want to make sure that your work is as easy as possible to be marked. So now I've done this one as well. X is greater than 2y. So we're going to draw the line x equals 2y. So if we have our x and our y here, now there's going to be a point at 0, 0, which is fine. And then we need to know one more point. So let's choose a suitable value of x, so somewhere quite far along. So let's go with 20x. If x is 20, what's y got to be? Y's got to be 10, because we double y to get x. So I'm going to draw on a line now that starts at 0, 0, and it goes 20 along and 10 up. So then if I join those 2 points up, I've got the fourth line I need on this axis. So let's just as accurately as I can. So this is the line of x equals 2y. And now the final line that I need to draw was the one from part A, which was that 2x plus 3y was equal to 5. So there's a bit of a mistake there. Just corrected that one through. So 2x plus 3y is less than or equal to 72. So 2x plus 3y equals 72. And now we'll start by choosing my 0, 0 values, so x and y, 0 and 0. So when x is 0, this part of the function is 0, so 72 divided by 3, which is going to be 24. And then when y is 0, this whole thing there's 0, so I've got to do 72 divided by 2, which is 36. So I'm plotting the point 0, 24 up to here, and I'm plotting the point 0, 36, which is over here. And then I'm going to join those two up as well. So I've got my lines like that. Now I want it to be less than that, so I want to go below this line. So I'm just another bit of rough shading there. And also I want x to be greater than or equal to 2y, so I want below this line here. Okay, so my feasible region then is going to be this yellow region here. So it's very important to label that as feasible region, or FR, so that and that is actually worth a mark. If you don't label your feasible region, you will lose a mark. Now, the final line that we need to draw on here for all 7 marks is the line for the objective function. So let's just change colour. We'll go to green. So 15x plus 20y equals p. So what we need to do here is choose a suitable value of p to be able to rearrange this equation to find its gradient. So I'm going to choose a value of p that's both in the 15 and the 20 times table. So I'm going to choose a value of 60. So to create a profit of 60, what do I need? So let's rearrange, well, let's now just substitute in some points, sorry. So x and y, and we'll go again with the 0, 0 method. So if x is 0, this whole thing here is nothing, so y is equal to 3. And if y is 0, this thing here is nothing, and x is equal to 4. Now that's reasonably straightforward to plot on here, although it is slightly smaller. If you wanted to, you could times everything by 10. So you could have everything to be 600, which would give me 30 and 40, which is then really simple to draw on here. So then joining those two lines up, obviously in the exam you're expected not to use different colours. The only reason for that is because your exam script is scanned in. So there's no reason why for yourself you can't use different colours to make this make sense, but you must make sure that you label everything. You don't use light colours because they might not show up. So this is then my objective line. So that gradient is really important. To finish off this question then, I'm now going to maximise this function because I'm trying to maximise profit. So when you're going to do this, you're going to take your ruler and you're going to move this line to find out where it's biggest in the feasible region. So where do we make maximum profit? So as I move this line up, I'm looking to see where the y value is at its biggest. And it's going to be at this top point of the region. So it's going to be up here. Now, what we can do is we can try and solve this by looking at it, or we can try and solve it using simultaneous equations. And just looking at what I'm working with here, I think I'm going to just show you how we do this as a series of simultaneous equations. So what we've got to work out is, firstly, where are the two lines crossing each other? Which are the two lines that are meeting to give us this maximum value? And so I'm just going to give myself a bit of working space by removing the inequalities. So this is where labelling your lines really comes into its own, because what I'm looking for is this intersection point here, which is the intersection of x plus y equals 32 and 2x plus 3y equals 72. Okay, so at this point I'm just going to solve this simultaneously. So there are lots of methods for simultaneous equations. I'm going to double the first one to give me 2x plus 2y equals 64 and subtract it away to give me a y value of 8. Then substitute that y value into the first one. X plus 8 is 32. So x is equal to 24. Now, what this method allows you to do is to, obviously, even if your diagram isn't particularly clear or you have made mistakes on that, you still should get the right answer here. Obviously, there's other points that the objective line tells me not to use, but there's this point here, this point here, or this point here. And you could actually, if you've got time, try all 4 of those points to find which one maximizes your function. So we're going with this so that y is equal to 8 and x is equal to 24, which tells me that I'm making 24 luxury hampers and 8 special hampers. So this is the number of special, this is the number of luxury. So you'll remember that we've obviously got an objective function that we're trying to maximize. So that objective function was 15x plus 20y equals profit. So we're going to substitute these values in. So 15 lots of 24 plus 20 lots of 8, and that will then give us our profit of, let's just do this one, grab the calculator. So 15 lots of 24 plus 20 lots of 8. So our maximum profit is 520. Now you must write the pound sign. If you just write 520, you will only get 2 of the 3 marks there for your final maximizing of this function. So we found all the inequalities, drew it onto our graph paper, and then finally maximized the function, solving it using simultaneous equations.